Can you hear me? Hello?
Hello, Professor.
How are you doing?
Good in yourself.
Fine, thanks.
Hi, Professor. I can hear you.
Okay, hello, very good. So we can begin then. Let me share my screen. Okay, there's one more person I need to admit. I got one more person. Okay. All right. So now you can see my screen, can you?
Yes.
Okay,
Yes.
good. Very good. Now this is where we start tonight. The mean, variance, and standard deviation of a probability distribution. Last night I introduced you to probability distribution, so let's do more work on that. Give me 1 minute. Let me open the calculator that we need. Okay, I think I can open it from here. Desmos. Yep, I think I can open it now. Good, excellent, 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 excellent. Let's see. All right. You can see the calculator and you can see me. This calculator, and you can see the handouts. Good. Now, the mean. You remember last we finished mean, median, mode, variance, and standard deviation. Those ones are for frequency distribution. The one we're doing tonight is for probability distribution. So it's a different formula. They mean the same thing. It's just that the formula for finding them are different. For a probability distribution, the mean, which you have this symbol mu, is sum of x times the probability of x. The variance with the symbol delta square is, but remember that this symbol here means sum. That's mean to add. That's means sum. So sum of x squared times probability of x, then minus the mean squared. The standard deviation is, which is have the symbol delta, is the square root of variance. So let us look at this, see how we can apply these formulas. The first example we're looking at tonight is this one here. Let me make it bigger. Probably we might need to move it down, but let's see. It says here that a bank president feels that each savings account customer has, on average, 3 credit cards. When you say average here, it means mean. So if he was claiming that each of his customers that have a savings account have, on average, 3 credit cards. Now, the following distribution represents the number of credit cards that people own. Number of credit cards: 0 credit card, 1 credit card, 2 credit cards, 3 credit card, and 4. So, and their corresponding probabilities are given. It says here, find the mean, variance, and standard deviation. Then B part says, is the president correct? Now, there are 2 ways you can do this, but I prefer to use the shortcut method, which involve putting these numbers in a table form like this one here. Number of credit cards, x, their corresponding probability is px, then you get x times px, x squared times px. So let's get them from, so x times px means this one here times this. So 0 times 0.18 give us 0. So every number multiplied by 0 give us 0. I think I have a copy of this table in my book, just to make it faster. Yeah. The 1 minute. Oh. Okay. Okay, I got it. Now, 1 times 0.44 give us 0.44. 2 times 0.27. So we got 2 times 0.27 give us 0.54. So taking it there, 0.54, that give us 0.54 for this one. So following the same process, I'll put the rest of them here. 0.24. Okay. 0.12. So when you add all this, you'll get 1.34. So why do we need to get this part? Because the first formula for main is x times px, sum of x times px. So that is what we have here. If you add it, we get this. For x squared means to square all this. The first one will be 0 square is 0. 1 square is 1 times 1 is 1. 2 square means 2 times 2. You can see right here squared. 2 times 2 is 4. 3 square means 3 times 3 is 9. And 4 square means 4 times 4, 16. So now we don't add this one because we only need it to get this part. So let me just center it in the middle. So we need it to get this part. But this part means s squared times px. So s squared times px is from here, this x squared here times this one. Okay. So we have it s squared times px. That means this one, see, from here multiplied by px. So 0 times 0.18 is 0.00. 1 times 0.44 is 0.44. Now 4 times 0.27, we got 4 times 0.27 is 1.08. So we go there and put it 1.08. That 1.08. So following the same method, I'll put the rest of them. 1.08, 0.72. We got 0.48. And when we add all this, from this all of these numbers here, you're gonna get 2.72. You can double check it with your calculator. So we have this point here, okay, and this point here, okay. So that we have this one, 1.34 is x times px, and you can see it right here, x times px. So the sum of it is this one here. Sum of x times px is 1.34, which gives us that the mean, which is sum of x times px, is equals 1.34. Let me make it big. See, so we have found the mean, 1.34. Any question on that? Any question? Good, no question.
So
Good.
what you're saying, yes, wait a minute. So what you're saying is that once we add the x times the p and the x, that will be our, that's our means. That's what you're saying, right?
Yeah, the sum of it. The sum of
Okay.
it. Yeah, when you add all of them, all of the x times px, we add all of them, that'll
Okay.
give you the mean. Yes.
All right.
Then second one is the variance. So find the variance. And for variance, we have the formula here. Sum of x squared times px minus the mean squared. This is x squared times px. This is the sum right here, which is 2.72. Okay, let me make it big. Let me make it big. Let me make this a little big. Okay. So 2.72 is the sum of x squared times px minus the mean, say minus mean squared. And our mean is 1.34. So minus 1.34 squared. 34 squared. See, and that will give you the variance. Okay. So now 2.72. I'm gonna write this down. 2.72 minus 1.34 squared. So we got 2.72 minus 1.34 squared. So we can go and put it on our calculator. So we have 2.72 minus 1.34 squared. That will be 0.9244. 0.9244. So we'll go back and put it in. 0.9244. 0.9244. So that's our variance. So, and they also want us to find the standard deviation. Standard deviation is the square root of the variance. It is the square root of the variance. Okay. That means the square root of this number here, which is square root of variance. So this is going to be the square root of, let me write the variance first, then put the square root of that there. The square root of, okay, I didn't put it well. Let me clean it. Okay, let me type the variance first. 0.9244. Now I'm going to make it big so that you can see it properly. Make it 18. So square root of that. Okay. So I'm going to put the square root sign now on top of it. The square root of that. See? Now, I will take you to the calculators where you can get the square root and type it in. From our calculator, we have square root, clearly square root of 9244.9244 is 0.9615. Square root of 0.9244 is 0.9615. So I'll take you back so you can type it in. So we have 0.9615. Okay. So that is it. Mean. So we have answered the question. The question wants us to get the mean, variance, and standard deviation, and we answered all of them. That's the part A. Any question before we go to part B? Okay, good. Now, part B says, is the president correct? Now, remember, the president is claiming that each current savings account customer have, on average, 3 credit cards, right? But our mean here is 1. Yeah, on average, 1 credit card, approximately 1. So, but he's claiming that they have on average 3. So, is that claim, is it correct? Is it correct or not? He's not correct, of course, because
It's not correct. Not
because he's
correct.
because he's claiming that they have 3 on average, but our average says 1, right? 1.3. So he is not correct.
Yeah.
He is the president. President is not correct because our average mean, which is the average credit card owned is 1.34, which is 1 credit card, basically, which is 1 credit card. Whereas he claimed that they have on average 3 credit cards. So that's why he's not correct. Okay. Now have B. So I'm gonna save this. Okay. So we have answer. So this is how we do expectation. I mean, sorry, mean, variance, and standard deviation of a probability distribution. Now let's look at the application here. The application comes under what's called expectation. The expectation is another name for what's called the expected value. So the expected value of a discrete random variable of a probability distribution is the theoretical average of that variable. Just like asking you to find the average, which you just did. Like here, they asked us to find the mean, which is mean means average, variance, and standard deviation. So they asked us to find the 3 things here, but under expectation, they want you to find only the average, and that average is what we call the expectation or the expected value. And the formula is mean, which is average, equals sum of x times the probability of x. So let us apply it to 2 examples. The first example will have to do with the lottery. It says, a lottery offers, make it bigger. So a lottery offers $1,000 prize, $1,000 prize, one $500 prize. Oh, excuse me, no, put all this is away. Okay, and the 5 $100 prizes. 1,000 tickets are sold at $3 each. Find the expectation if a person buys 1 ticket and if the winning ticket is returned to the pool after each draw. So the first thing we do here is to make a table of values. So and there are how many prizes? 1, 2, then plus 5. There are 7 prizes to win. Then plus, if you don't win at all, remember you spent $3. If you don't win at all, nobody will give you your money back. So that will be a loss. So we're gonna let's put a table in. See, I think I need to put one more. So you can see that we have win. Okay, what's it? Find win. Win will be our x. Okay. All right. Then we have our x. Next would be is x. I put it in parentheses. Win x. Or I can just put it win x by x. Then the probability of x is px. It means the probability of x. That is the probability of the win, of getting the win. So if assume that you win $1,000, let me make this a little bit, yeah, I think it's good enough. But Let's make it like this. Oh, you know what? Okay. I think that you win you won $1,000. They will not give you, they will give you a check of $1,000, but your actual gain is $997 because nobody will give you the $3 that you paid back. So your net win is $997, even though they'll give you a check of $1,000. So I'm gonna write, instead of writing the $1,000 here, I'm gonna write the net winning, which is $997. The same thing applies to $500. When you win, they'll give you a check of $500, but your actual win is $497 because nobody will give you back the $3 you spent. So that means here will be $497. So following that process, the $500 win, see, there's a price for $100 and there are 5 of them. So that means that your net win is $97 for the 5 of them. 97, 97, 97. How many now? 1, 2, 3, 4. But there are 5 of them. 97. Now, of course, you can also lose, and if that happens, that happens most of the time anyway. If that happens, that means you lose your $300. In that case, it will be negative $3, since you are losing the $300. So now let's look at the probability of each of these. Okay. Now, you know that the chance that you win, there are 5 prizes. How many prizes? 1, 2, 3, 4, 5, 6, 7 prizes. Now, 1,000 tickets were sold. So your chance of winning any prize is probability of win is, because you bought only 1 ticket, 1 out of 1,000 tickets. Okay, making it a little bit bigger. 1 out of 1,000 tickets, that's the chance of winning it. So looking at our calculator, we have that 1 out of 1,000 tickets is 0.001. Okay, 0.001, 0.001. Now, the probability that you lose, probability of losing, okay, lose will be, now, there are 7 prizes to win, right? 7 prizes. So the probability that you lose will be 1,000, okay, minus the 7 prizes divided by 100, 1,000. So you're gonna have 1,000 minus basically I'll put it this way: there are 7 prizes, so you can call it 7 times, okay, times 1,000. 1 divided by 1,000. For each of them, we have 1 over 1,000 of chance of winning. See, so it's like saying 7 out of 1,000. So I'm gonna put it here. We got 7 times, okay, 1 divided by 1,000. Okay. Oh, I used the wrong formula. That was the wrong formula. Let me put it this way. Let's go back. I'll take that back. So chance of losing, let me put it, if you have 7 prizes, 1, 2, 3, 4, 5, 6, 7, 1,000 minus 7, I would be put it that way, 1,000 minus 7, okay, divided by the answer is 993. So divided by 1,000. So the chance of losing will be I put it this way. Out of 1,000 price, out of 1,000 entries, you lose 7 prizes. That's minus 7. That's the opposite. Divided by 1,000. Okay. So that's what we gotta put in the calculator here. So we have it. Put it right here and here. Divided by 1,000. Like in 0.993. 0.993. So that's a chance of losing. So we have it here, 0.993. 0 points. So now we put all this in the table here. For this, the chance to win 997 is 0.001. The chance to win 497. Actually, this is to win 500. But remember, they give you a check of 500, but your actual win is 497, since nobody will return your $3 back. So 0.001. To win 97, for all the wins, the probability is 0.001, because for winning is that what it is. So you have it for all of them, 0.001. Okay, 0.001. Okay, 0.001. Okay, 0.001. Okay, now 0.001. And for losing, you have this 0.993. 993. So now we have our win and loss, the wins here. So we can now make a table of values with this and then calculate our probabilities. The table of values can go this way. I can use this this one here and put it here, then expand it. You're gonna have win, and probability of win. So I'm gonna expand this. Okay, our win is 997, 497, 97, 97, 97, 97. There are 5 of them. 1, 2, 3, 4, 5. Okay, I have 1, 2, 3. So I have one more. 97. And of course, you lose. That means that's gonna be -3. And the probabilities are written from here. All the wins have the same probabilities. 0.001. So I have 0.001. 0. Okay, excuse me. 0.001. 0.001. 0.001. 0.001. 0.001. 0.001. 0.001. Now for loss, you have 0.993. 0.993. So you can have our totals here. Totals. Okay, so I'm gonna make all this in centered. Okay. All right. Save this. So I'm gonna upload it for you. Now, with this, we can now get our x times ps. Remember that the mean, we are looking for the expected value. The question says, find the expectation. And the formula for that is sum of x times px. So let's get x times ps first. X times px give us 997 times 0.001. Okay. 997 times 0.001, 0.997. So you go there and put 0.997. Okay. 0.997. Following the same process, multiply all of them. This will give us 0.497. This one give us 97 times this will give us 0.097. This one will also give us 0.097. You can double check it with a calculator at home. 0.097, 0.097, 0.097. Now this one negative 3 times that. So we have negative 3. Okay, negative 3. Negative 3 times 0.993. So I'm gonna write this down. My book. 0.993. Give me 1 minute. Let me put this in out. Okay. Write it down. It gave us negative 2.979. So, taking you back there, negative 2.979. Now let's add a total to get it, our answer, our expectation. So it's going to add all this. You can double check this with your calculator as we add it. Okay, got okay 0.997 plus 0.497 plus 0.097 plus 0.097 plus 0.097 plus 0.097. There are 5 of them. I want 4 now. Plus 0.097. Now plus the other one is negative 2.979. 2.979. Give us negative 1, which means a loss. If this answer is positive, that means you're gaining. But with lottery, it's usually a loss because most of the time you lose. So the answer gives us negative $1. Negative $1, which represents a loss. So that our expected value, which is sum of s times s, is negative 1, equals negative 1.00, which is a loss. I'll make it big. Loss. Okay, I'm gonna make it from here. Make it look big enough. Okay. So our answer the question. The expected value is negative 1, which is a loss. Any question on this? Any
So
question?
why is it when it gave us our answer, it gave us 1? So why did you put 3 zeros behind?
Because you see, each of them have 3 digits. 1, 2, 3. After the decimal point.
Got you. Okay.
Yeah.
All right. All right. Got you.
Even if you like, even if writing, it's 0 after the decimal point, it's still not significant. Even if I have it like this, we are still good. Yeah. It's just to put the placeholders. So in this time, you can see that with lottery, you are most of the time you are losing. That's why you have negative. If it's a business, if it's negative, that means that business will not be profitable. If it's positive, that means you're gonna gain. So now we have only 6 minutes left on this side. We cannot get anything done in actually 5 minutes. We can't do much in 5 minutes. So I will time us out. Wait for 10 minutes. Log back in. Okay, let's round up. Okay.
All right. 10 minutes.
10 minutes. Yes.
All right.
All right. See you back in 10 minutes then.